Hi, I'm Bob Tabor with LearnVisualStudio.net. In the previous lesson, we added the recipe data source.cs to our application, and we wired it all up, and it all worked. See how easy it is to build Windows 8 apps. Oh, okay. Well, there's quite a bit of work that went on behind the scenes to make this all come together so smoothly. And so to satisfy our curiosity and to prepare us with enough information so that we can create our own data access classes in the future, I want to pick that file apart and really see how it works, what makes it tick. We've got to understand how it works and why. And so I'm going to start by calling your attention to what might at first seem like two completely different ideas, but I want to show you how they're related together. So first of all, you remember we left off at this diagram in the previous lesson, and we saw the inheritance hierarchy. This class inherits from this class, which inherits from bindable base, right? And you know, we never really answered the question, well, what's bindable base do? Why is it there? What action is it performing, or function, or what's been delegated? What responsibilities does it have? All right. Furthermore, let's leave that idea and then go back into our code. And if you take a look at our new recipe data source and we scroll down through it, especially in like the recipe data group, we've seen this observable collection of T. And I think we'll see it used again here in the recipe data source class itself. Here's another observable collection of recipe data group, and so on. We see it's employed a couple of different times here. Now we've looked at a related idea, the iObservable map of KV, and we noted that one of its superpowers was change notification. And so I want to elaborate on that idea in this lesson. So if we were to take a look at bindable base, so let's go to the very top of this and notice that our recipe data common, from which data item and recipe data group derive from, that it itself derives from bindable base, just like our diagram pointed out. And so if I right click and select go to definition, we see that it is defined, and let's just show you where it's at here in this common folder. We have this bindablebase.cs, all right? And you can see that bindable base derives from something called iNotify property changed. And so before we dive deep into this, at a high level, bindable base and the observable collection of T are actually related in a sense. They allow for change notification in our recipe data item and recipe data group objects. Change notification is simple. If our underlying data changes while the app is running, we want those changes to be reflected in the user interface. So this really comes in handy when you've, for example, connected to a web service. You ask the web service every 30 seconds, is there anything new? Are there any changes? Is there anything that I need to show the user differently? All right. And then the web service gives you an updated set of data. And now some of that data represents objects that have been added in the past 30 seconds, while others have been deleted in the past 30 seconds. Still others have been updated, their properties have changed in the last 30 seconds, and now you want all of that information updated in your user interface. And that's what this code accomplishes, all right? So, let's get back here and go back to the observable collection of T, and then we'll come back to this bindable base. So, observable collection of T. We can see that it's used throughout this recipe data source whenever there's a collection of items. Now, you might be wondering, hey, why didn't they just use list of T? We saw that and we learned about it in the C# Fundamental series, right? And it seemed pretty easy and obvious to use. However, if we did that, then we would need to add all of the code required to check for changes in the data inside of that list, and then manually update the user interface for each item that's been added or removed. While that's certainly possible, we get all that for free from the observable collection of T. It already does this for us. All we have to do is let the observable collection of T know which items have been added and removed, and it notifies all the user interface elements that were bound to the collection. So those user interface elements, in turn, they receive the change notification event, and then they update the data that they're displaying. No extra code to write, it just works. All right, so what about changes then to individual objects in the collection? For example, what if a recipe data item's ingredient list were to change while the user has the application open and he's viewing it? Or more likely, what if the rating or the comments for a given recipe were to change? Wouldn't you want those to show up? Wouldn't you want that while the user is watching it to see real-time data and have it displayed in the user interface and updated? Well, in that case, if you're just updating an existing object inside of a collection, then you have to do a little bit more work on your own to raise that change notification event manually and say, hey, I changed. You need to update the user interface to reflect the change in my title property or the change in my ingredients property, for example. And so that's what the bindable base is doing for us, all right? So as you can see, bindable base implements this iNotified property changed. It raises an event called property change, and that's what this contract enforces. The fact that now this class will raise an event whenever a property changes. And so you can see how it's declared by agreeing to the terms and the conditions of the iNotify property changed contract. This class says, I'm going to send notifications. You can go ahead and bind to me. I promise to let you know when things change, and I'll do so by broadcasting a property changed event, which actually happens like right here, all right? Now, the user interface elements can trust this class and any class that derives from it, like our entire inheritance hierarchy, to follow these rules and offer change notification when one of its attributes, one of its properties change. So much of the bindable base is then making sure that a given property inside any class that inherits from it is actually changing. It guards against the possibility that, for example, set property is called, but the new value is the same as the old value. If that happens, then return false and don't call the onPropertyChanged event, which is declared below. So if this happens, if what the original value of a property and the new value of the property are exactly the same, then it will not fire off the change notification. Why? Nothing's really changed about it, okay? So that's the idea here. And so this set property then is used, if we take a look at our recipe data source, take a look at recipe data item, for example. Every time there is this pattern of a public property and its private field, look at the setter. In every setter, it's calling this set property, set property, set property, okay, on all of its public property setters. And it's passing in a reference to its private member variable as well as the value that it's attempting to set it to. So we're sending in by ref, not by val. And you set by ref whenever you intend to make a change to a value inside of a method, okay? And so you can see that's what's going on here. Bindable base. Take a look. So we're receiving that reference, and then if storage and the value we want to set it to are not equal, then this code will execute, and the first thing it'll do is it'll set the value of storage equal to the new value that it's attempting to set it to. And then it calls the onProperty change. There's also this interesting little attribute or adornment that is added on to the property name. So this caller member name is new to C# 5.0, and it will basically send in the name of the property that's being set. So in this case, it will send in ingredients. In this case, it would send in directions as the name of the property that's being changed. And why is that? So that it can then be used in this property change event args as it's raised as the event handler. The notification property changed is broadcast, okay, to everybody who binds to it. All right. So then the user interface can say, oh yeah, I know about directions, or I know about ingredients, and that's my job to show it. I guess I better update it. And that's how that works. Okay? All right, so let's continue on from there. I think we've exhausted that thought process. But if you ever get confused, just set a breakpoint here, and then run the code and see how it all works. Just hover your mouse cursor over and see the current values, and then really think, what's this logic attempting to do? All right, and I think that helps a lot, especially when I'm trying to pick something apart and really understand it. All right, so let's get back here to the recipe data source.cs. I'm going to roll this back up. We've talked about the recipe data item and the recipe data group and their inheritance hierarchies. What's left is this recipe data source, okay? And this is where the text from our recipes.txt is loaded into memory and then parsed, and we create instances of the recipe data item and recipe data group. But before we talk about that mechanism, how that's working, what I want to do is take a look at several smaller curious details about the recipe data group and the recipe data items classes. For example, you'll notice this interesting pattern here where we have both the tile image path and the tile image itself. So this is purely a URI, a uniform resource identifier. It's the location for where our images are saved, and it is saved in this property called base URI, which is part of the base class recipe data common. So let's go up to recipe data common and take a look here, and we see this internal static URI base URI equals new URI ms-appx : //. Okay, so what is this? Well, internal is a visibility modifier, much like public, private, or protected. This just means that any code that is defined inside of the project can access this, but if it's a file that lives outside of our package, it cannot access it. All right. Static, we already know what static means. That means that there's just going to be, there's no instance of this per se. It's just a constant, I guess you could say. All right. We've already talked about what the URI class is. It just represents a location. All right. And then what is this? Well, this is a special indicator, I guess you could say, of where where a given command should look for a resource. Now, we might expect to see something like http : / or ftp : /. This is a Microsoft specific format that indicates inside of the deployment package. So somewhere inside the deployment package, we're going to look for, in this case, the image. So that's the base of the URI, but then the image path, we would expect to pull that and have that gain that from the recipes.txt file. And so if you were to look at some of these, you can see that, for example, this background image at the very top, it's in the images Chinese 1600c.jpg. So those two things get combined together, the base URI and then the given image path, and then we can use that to read the data into a data stream and construct a bitmap image in memory from that URI. All right, so we're going to read it from the deployment package, and now it's an image, and we can bind to it, and they would actually see on screen, whatever the recipe bitmap looks like. Okay. All right, but you see that where we have both the image path and the image source displayed. And almost every time there's an image, there will be this pattern of having the two as independent properties. And therefore, whenever you want to set the image, notice what it's doing here. It's saying take whatever image, which represents the image source, and remove it from memory by setting it equal to null, and then give me the new path, the new place where to look for this image. And so it's essentially only setting the path here. Then the next time that it's requested, the image itself, then it's going to say, hey, if this image this image is null and this image path is not null, then go ahead and create a new instance of bitmap image. Otherwise, just return the fully functional populated image that we already have a reference to. All right. So again, just take some time and stare at this, but you shouldn't have to duplicate this in this project. But again, if you wanted to add images in, you would need to understand this little pattern that they use and why they're using it. But essentially it is to avoid an expensive operation in memory or on disk access for creating new instances of images every time you touch them. It would only create it whenever the image path, or rather the image source, has changed. Okay. And we've already noted in all these properties how it uses the set property and the setter. We've already talked about that. The getters are all pretty simple. They're just returning the value of the private member that is the backing essentially for the public property. That's pretty typical stuff. Each of these classes have a constructor that would allow you to pass in the various properties at construction and get the object into a valid state right off the bat. All right, so I think we've covered the basics, the patterns that are used most often inside recipe data item and recipe data group. Okay, so let's just move on from there. There's another curious detail if we start looking at the recipe data source itself, that we have a private static recipe data source. Wait, what? The class recipe data source has a static member of type recipe data source, and it creates a new instance of its class. Okay, what is going on here? Well, it's a software pattern called singleton, and it prevents there from being a bunch of instances of these classes floating around. So instead, you can always be sure that you're working with the same instance of the class no matter what. It obviates the need to keep creating new instances of this class, repopulating the data from the text file every time that it's accessed, since that is potentially an expensive operation. It could slow the app down. So instead, there's just one instance of the class. It's used everywhere throughout the life of the app, and that's what this is intending to do. Okay, so we can use it then like we see in our like here, for example, recipe data source. How are we able to just use it like a static class? Because this is a static member of recipe data source that gives us access to a single instance of recipe data source, at which point then we can call get item and pass in whatever we need to pass in. Okay. Okay, so I think we've covered a lot of ground here. There's still a little bit more to talk about with regards to the specifics of the recipe data source and how it actually uses this load remote. Well, actually not that one. Let's skip that one. Load local data async, okay? How does it actually grab the data from the recipes.txt file, and then what is this code doing, the one to create recipes and recipe groups? How is this working? And then what's this little helper method doing, create recipe group? All right, we'll talk about that in a little bit. But in closing, let me give you another word of encouragement. I realize that there are a lot of class names and interface names that are flying around here at a rapid speed, okay? If you ever get confused, you have to stop down and you have to ask yourself the critical question, why? Why is this interface being used? Why is this specific collection being used? What is the purpose of this class? Is this class or is this collection native to the framework, or is this something that's been created inside of some nook and cranny of the code, for example, in our layout aware page, for example, okay? So I think that, you know, the best way to learn is to be a critical thinker, to identify and ask yourself the critical question, why? Then you set out to discover the answer, which inevitably leads you to more why questions, and that's a good thing. It keeps you fresh and engaged and growing and excited about the work that you're doing. I know that certainly is the case with me. Okay, so now what we're going to do in the next lesson is we're going to pick apart this recipes.txt file. We're going to talk about this file format, and then we're going to talk about how it's brought into the project and parsed through to create instances of groups in recipes. See you in the next lesson. Thank you.